Hi everyone, in today's video we're going to be talking about forces. Why does an object accelerate from having a constant velocity or being at rest? It all has to do with a force influencing this motion. So to start studying dynamics, we're going to review the 3 Newton laws of motion. Coming right up. Before we start with this video, if you are liking this channel and the videos I'm posting, do not forget to subscribe to it. However, let's start with forces right now. What forces, if any, cause the moon to orbit around the Earth? Forces are what cause any change in velocity. The moon's velocity changes in direction. Remember that velocity is a vector, so it has direction and magnitude. By changing direction every time it moves around the orbit, then the moon is actually changing velocity as well, because it's changing one of its components. The only reason that the moon is orbiting around the Earth is because a force is being applied on the moon, and this is a very known force called the gravitational force. We can divide the forces into 2 different categories. One of them is contact forces. These type of forces, they require contact between the 2 objects. So for example, kicking a ball or pushing a shopping cart, anything that requires you to have contact with each other. The other type of forces can be considered field forces. Field forces are, for example, the gravitational force we just talked about. Electric forces. So if I have a proton that's positively charged and an electron that's negatively charged, they attract each other without touching each other. So you have a force that's attracting the 2 charges, or that's repelling 2, for example, positive charges or 2 negative charges. So that's another type of field force. Now let's go back to Newton's laws. The first law, also called inertial law, only states that when an object is at rest or moving at a constant velocity, this object will remain at rest or moving at a constant velocity unless a force is applied to it. A good example of this law is when you're in a car and you accelerate suddenly. So you change velocity, you increase your velocity, your body will move backwards, and that's because your body wants to remain at that constant velocity. The important thing of this is that an object will not just change velocities without a force being applied to it. So Newton's first law explains what happens to an object when no forces are applied to it. But what happens to an object when one or more forces are applied to it? This takes us to Newton's second law of motion. If we push an object with mass m across a room with force F, and the object will move with some acceleration a at 2 meters per second squared. If I double my force, so I make it 2 times F, then my acceleration is proportional to that. So instead of moving at 2 meters per second square, if it's the same mass, it's going to move at 4 meters per second square. The same happens if I triple that, then the acceleration will be 6 meters per second square. This only tells us that the force applied to an object is proportional to its acceleration. If I'm pushing a box, that's 3 kilograms and it's moving at 4 meters per second square. If I add on top of this box another box that's also 3 kilograms, then having a 6 kilograms to push with the exact same force, I'm going to get an acceleration that's half as much. So it's 2 meters per second square. That tells us that the acceleration is inversely proportional to its mass. Your acceleration is proportional to your force and inversely proportional to your mass. If we want to solve for force here, then you have the force equals to your mass times your acceleration. But force is not only one force applies to an object. An object has one mass and it moves at a certain acceleration at a time. But it might have one or many forces being applied to it. So what you have to do is get the sum of all these forces with its direction, and then once you get the net force, then you equal to the mass times the acceleration. So let's look at the units here. I have my force or my sum of forces. and that equals to my mass, which is in SI units, is only kilograms, and then I have my acceleration, which is meters per second squared. So my force equals to 1 kilogram times 1 meter per second squared. Okay, so this means that when I apply 1 unit of force on these SI units, I can move 1 kilogram of mass 1 meters per second squared. So we call this unit of force a Newton. Now that we have defined Newton's second law, let's move on to Newton's third law. Newton's third law states that if two objects interact, the force of the first object exerts on the second one is equal and in opposite direction than the force that the second object exerts on the first one. I have my F, and then I have 1 of 2, which is what the first object is exerting on the second one. That equals negative F of 2 of 1. Let's consider an example of a TV sitting on a table. Since every force must have the same magnitude force as the reaction between two objects, but in opposite directions, we can see that the table exerts on the TV an upward force, which we usually call the normal force. The normal force is up to any value until the TV breaks the table. Because the TV has zero acceleration, it's just standing there, it's not moving in any direction, we can consider the equation from Newton's second law of the forces applied on the TV to be the sum of your force equals to your mass times acceleration, or the sum of the forces equals to 0, because we don't have any acceleration. But what is the sum of these forces? So we have the downward force of gravity plus the normal force of the table. So my sum of forces is normal force minus my gravity, what the force is applied on the gravity. So that is also called the weight. So your weight is only that, is your mass times the gravity that's being applied on you. So in the next videos I'm going to be posting this week for Newton's laws, I will be solving problems related to these equations and to these Newton's laws of motion. Don't forget to subscribe to the channel so you can be getting the new notifications. However, if you do understand the concepts that we just talked about in this video, it should be very easy to solve. Some problems just have a little more trigonometry than others, but it shouldn't be hard. These problems are very straightforward. If you have any questions regarding any of these, if you would like to see any specific type of problems, please let me know in the comment section below.